Hi scholar, welcome to Post Scholars channel. Are you preparing for WAEC exam, NECO exam, JAMB exam, or any other high school exam? Then this video is for you. So the title of this video is Quadrilaterals and Polygons in Geometry. Now take note, I would like you to follow this video to the end, right? Because it's a necessary foundation for solving problems involving quadrilateral and polygon in general, right? So please stick with me as I walk through the explanation, right? So the first subtopic is quadrilateral, right? A quadrilateral is a polygon with 4 sides, 4 angles, and 4 vertices. Two properties here are: one, the sum of interior angle of any quadrilateral is 360 degrees, and the sum of the exterior angle is also what? 360 degrees. What does that mean? This is point A, the vertex A, vertex B, vertex C, and vertex what? D, right? We have explained the vertex part. 4 vertices. Now 4 sides: first side, second side, third side, and fourth side. And the next one, 4 angles, right? 4 angles. Let's count the angles: 1, 2, 3, and what? 4, right? So a quadrilateral has 4 sides, 4 angles, and 4 vertices. Then another information is that when you sum all the angles, right, it must equal what? 360 degrees. It must not be more than 360. When you add this angle, this angle, this angle, and this angle, they all sum up to what? 360 degrees. Same thing, the exterior angle is the angle outside. For example, for this angle, the exterior angle will be when I extend this line. So this is the exterior angle, right, for this. Then same thing for this angle, the exterior angle will be when I extend this part also, right? So this is the exterior angle. For this part also, this angle, the exterior angle will be when I extend this line, right? This is the exterior angle. Then, and lastly, the exterior angle will be when I extend this side. So this is the what? Exterior angle. It simply means if I label the exterior angle E, F, G, and H, the property say that when I sum up E, F, G, and H, I must get what? 360 degrees, right? And that 360 is just like a circle. If you remember, the sum of angle in a circle, right, is actually what? 360 degrees, right? So the exterior angle is acting like the bounded region of a circle, right? Next, types of quadrilateral. The first type of quadrilateral we have here is parallelogram, right? So what are the properties? The first property of parallelogram is that opposite sides are parallel and equal. So let's establish that opposite side equal. So here is equals to here, right? Parallel, so this side is parallel to this side, right? Next, this side is equal to this side. Are you following me? And also this side is parallel to this side. This is symbol for parallel. I told you before, right? Now, next, opposite angles are equal. What does that mean? This angle is equal to this angle, and then this angle is equal to this angle, right? Good. Next property, consecutive angles are supplementary. What does that mean? To explain that, I'll label here angle A, and I'll label here angle B, I'll label here angle C, and I'll label here angle D. Now, consecutive angle is saying that when I add up A and B, it must be supplementary. Supplementary angles are angles that add up to 180. That means A plus B must be equals to 180 degrees. Similarly, C plus D must be equals to 180 degrees. So that's the principle of consecutive angle, or it's also called co-interior angle, right? Next, diagonals bisect each other. Let's check it out. The first diagonal will be from here to here, right? The second diagonal will be from here to here. You can see that the diagonal indeed bisects each other. That means the length of here of this side is equal to the length of this side, and also the length of this side is equal to the length of this side. So these are the properties of a parallelogram. Please, you need to know it so that when you start solving problem, it will come in handy. You won't have to start flipping through your notes, right, to understand the principles and concepts guiding parallelogram. So next, rectangle. What are the properties? First property says opposite sides are parallel and equal. So equal, first of all, this side is equal to this side, right? This side is also parallel to this side, right? Similarly, this side is equal to this side, and this side is also parallel to this side, right? That's the first property. Next property is consecutive angles are supplementary, right? We don't need to bother ourselves because indeed each of this angle is 90 degrees. That's the property. Each angle is 90 degrees, right? So yes, 90 degrees is always represented with a small square. 90 degree, 90 degree, 90 degree, and 90 degree, right? So definitely the consecutive angle at this angle and this angle. So when you add it, indeed you get what? 180. So the next or the last property says diagonals diagonals are equal and bisect each other. So let's check and see how true. So the first diagonal is from here to here. Second diagonal is from here to here, right? So very true. The diagonals are equal. The length of from here to here is the length of from here to here. And the property also says the diagonals bisect each other. That means the length of here is equal to the length of here, right? And the length of here is also equal to the length of what? Here, right? So we have established the properties of rectangle. Next, square. Opposite sides are parallel, right? That means this side is parallel to this side, and also this side is parallel to this side, right? Next, consecutive angles are supplementary. That's very true because each of the angle in a square is 90 degrees. So which will be represented with a small square, 90 degree, 90 degree, 90 degree, and 90 degree, right? Next property says diagonals are equal and bisect each other at right angle. Let's check that. So the first diagonal is from this point to this point, and the second diagonal is from this point to this point. You can see it's very true. The length of this diagonal is the same as the length of this diagonal, and it's telling us that it bisects each other at right angle. So this is the point where the diagonals bisect each other, and the property is saying that this side is 90 degree, which is true. This angle is also 90 degree, this angle is 90 degree, and this angle is 90 degree, right? Then I think that's how we have established the properties of a square, right? So the next one, okay, all sides are equal, right? All sides are equal. Let's establish that this side is equals to this side, and is equals to this side, and is equals to this side. So all sides are equal. Next, rhombus. Now, the property of rhombus says all sides are equal, right? This rhombus, this side is equals to this side, equals to this side, and equals to this side, right? Opposite angles are equal, right? That means this angle is equal to this angle, and this angle is equal to this angle, right? So next, diagonals bisect each other at 90 degrees. So the first diagonal is running from here to here, and the second one is running from here to here, right? So diagonals bisect each other at 90. That means at this point where the diagonals bisect each other, the angles subtended are 90 degrees. So we have 90 degree here, 90 degree, 90 degree, and 90 degree. Next, trapezium. This is a typical example of a trapezium. The first property says only one pair of opposite side is parallel. Let's establish that this side is parallel to this side, but take note, this side is not parallel to this side, right? Non-parallel sides are called leg. These sides that are not parallel called legs, right? So in an isosceles trapezium, this is an example of isosceles trapezium. The non-parallel sides, we have established that in a trapezium, two sides must be parallel. That means this side is parallel to this side, right? But then, since this is an isosceles trapezium, right, this side must be equal to this side. But if we check this particular trapezium, this side and this side are not the same. But when the side becomes the same, it has become an isosceles trapezium. So we can indicate that by saying this side is equal to this side. So if these two sides are equal, it simply means the two base angle will also be equal. So we can say that this angle is equal to this angle, right? So these are the properties of trapezium. Next, kite. Now, the first property of kite says two pairs of adjacent sides are equal. Two pairs of adjacent sides. So this side is adjacent to this side, and they are equal. And also this side is adjacent to this side, and they are also equal, right? Now, the next one says one pair of opposite angle is equal. What does that mean? One pair, just a pair. That means this angle is equal to this angle. But take note, this angle is not equal to this, and it's just a pair that is equal, right? So diagonals intersect at right angle. Let's establish that. The diagonal is running from this point to this point, and from this point to this point, right? So diagonals intersect at right angles. That means the angle subtended at the point of intersection is 90 degrees. So we have 90 degree here, 90 degree, 90 degree, and 90 degree. Good. Next, irregular quadrilateral. Now, irregular quadrilateral, what are the properties? Sides and angles are not necessarily equal. An example are quadrilateral without symmetry, right? So this shape is an example of irregular quadrilateral. Take note, symmetry simply means an imaginary line that bisects a shape into two equal parts. So this shape does not have any line of symmetry, right? So it's called an irregular quadrilateral. Next, polygon. Now let's talk about polygon. A polygon is a closed plane figure bounded by a straight line segment. Each line segment is a side. Each meeting point is a vertex. A polygon with 3 sides is triangle, 4 sides is quadrilateral, 5 side pentagon, 6 side hexagon, 7 side heptagon, 8 sides octagon, 9 side nonagon, 10 sides decagon. And this is a typical example in terms of diagram, right? So all these are polygons, right? 3 sides becomes triangle, 4 sides a quadrilateral, 5 side a pentagon, 6 side an hexagon, right? And on and on like that. Now, what are the types of polygon? The first one is regular polygon. All sides equal and all interior angles equal, right? So the shapes here are examples of regular polygon. Why? Because the sides and angles are equal. Here, or this polygon, which is a triangle, this side is equal to this side and is equal to this side. For this square, this side is equal to this side and is equal to this side, right? For the pentagon, this side equal, and equal, right? So whenever you see the word regular, take note. Whenever you see the word regular, it simply means the sides are equal. Take note of that. Very important, right? So we have talked about the regular polygon. Next, irregular polygon. Now, sides and angles are not equal. So this is an example of an irregular polygon because the sides are not equal, right? The sides are not equal. This side is not equals to this side, not equals to this side, not equals to this side, and not equals to this side, right? Good. Same thing with the angles. Now, the next kind of polygon we have is convex polygon. Now, all interior angle is less than 180 degree. This is an example of convex polygon. If you observe it, you see that this angle is not greater than 180, neither is this, neither is this, neither is this, neither is this, and this. So whenever the angle in a shape is less than 180, then the shape is a convex polygon, right? Next, concave polygon. At least one interior angle is greater than 180 degrees. So let's establish that this angle is less than 180, this angle is less than 180, less than 180, less than 180, greater than 180, right? And less than 180. So this shape is an example of what? A concave polygon. You can see a part is caved inward, right? It's caved inward. So this is an example of a concave polygon. Next, angle in polygons. Sum of interior angle of an n-sided polygon, right? If, for example, we don't know the number of sides of this polygon, right? The formula to find the interior angle, which will be this angle, this angle, this angle, this angle, and on and on. But for this shape, we actually know this number of sides. Number of sides is 5. But if you don't know the number of sides, it will be represented as n. So formula for finding the sum of angle in an n-sided polygon is given as n minus 2 times 180 degree, right? So this is the formula to find the sum of interior angle of an n-sided polygon. Please, in the next video, we'll start solving problem. I would like you to watch the next video. So please, because right now we are just doing an overview of what we are going to do, right? Next, measure of each interior angle, right? So if the sum of angle of a regular polygon is n minus 2 times 180, what will now be the size of angle for each? What will be the size of angle for each, right? The size of angle for each will now be n minus 2 times 180 degree over n, which is the number of side, right? Don't worry. When we start solving problem, it will be clear. But just know that this formula is for the sum of interior angle in the polygon, while this formula is for the size of one angle, right? The size of each angle in the polygon. Then next we have sum of exterior angle of any polygon. So take note, is 360. The sum of the exterior angle of any polygon is 360. Take note, this example of polygon with 6 sides. So the exterior angle will be represented as, so this the first exterior angle, this the second exterior angle B, the third exterior angle C, the fourth exterior angle D, the fifth exterior angle E, and the sixth exterior angle F. So what this formula is saying is that when you add up A plus B plus C plus D plus E plus F, the result is what? 360 degree. So take note, the sum of angle, irrespective of the number of sides, the sum of exterior angle of any polygon is what? 360 degree. Now, measure of each exterior angle. Now, since we know that these sides are all equal, definitely the size of each of the exterior angle, say for example, the size of just this will be what? 360 degree over what? N, right? N represents the number of sides. Now, symmetry in polygon. Now, line of symmetry, also known as reflectional symmetry. A regular polygon with n side has n lines of symmetry, right? For example, square has 4 sides. Definitely the line of symmetry, the number of line of symmetry in a square will be what? 4. Let's establish that. So line of symmetry means imaginary line that can divide the shape into 4. So if I draw one line of symmetry here, very true, you can see that you can actually fold this part into this part and you have the same shape. That's the first line of symmetry. The second line of symmetry will be here. You can fold it this way, right? The third line of symmetry will be the midpoint of this side going downward. You can fold it along this line. And the last line of symmetry is here. You can fold it along this side. So it has 4 lines of symmetry, right? Similarly, hexagon. Since hexagon has 6 sides, definitely the number of line of symmetry will be 6. Should we establish it? Yes, let's establish that. So the first line of symmetry will be here, right? It will divide the shape into 2 equal parts. The second line of symmetry will be here, right? Also dividing the shape into equal parts. The third line of symmetry will be here, right? Then the fourth line of symmetry will be the midpoint of this side, right? Going downward, right? That's the fourth. The fifth line of symmetry will be the midpoint of this part going downward, right? And the sixth line of symmetry will be the midpoint of this part moving downward. Good. So an hexagon has 6 lines of symmetry. Now, special theorem and facts. The first theorem we'll look at is that exterior angles theorem of polygon. The measure of each exterior angle of a regular polygon is equals to what? 360 degree over what? N. We have said that before. That's the measure of each exterior angle of a regular polygon. Take note, it must be a regular polygon. So this is the formula for finding the angle, each angle of the exterior parts of a regular polygon. Then next, diagonal of a polygon. Number of diagonals in an n-sided polygon. So the number of diagonal of an n-sided polygon is given as n into brackets n minus 3 over 2, right? So this formula helps you to find the number of diagonal in an n-sided polygon. For example, this polygon has 1, 2, 3, 4, 5, 6. Has 6 sides. Let's to find the number of diagonals in this diagram, we use this formula 6. So let's plug in 6. 6 minus 3 gives 3. Then 3 times 6 gives 18. 18 divided by 2 gives 9. That means the number of diagonal in this shape is what? Is 9. Should we try it? Okay, let's try it. So diagonal is any line touching 2 opposite angle, right? Any line touching 2 opposite angle, right? So the first diagonal is here. Let's do it together. Second diagonal, third diagonal, right? Fourth diagonal, fifth diagonal, sixth diagonal, seventh diagonal, eighth diagonal, and ninth diagonal. Good. So this formula helps you find the number of diagonals in an n-sided polygon. So next we have cyclic quadrilateral. So cyclic quadrilateral says opposite angle of a cyclic quadrilateral are supplementary. By now you should know the meaning of supplementary angle. There are 2 angles that sum up to 180. So whenever you see a quadrilateral which has 4 sides inscribed in a circle, the theorem is saying that the opposite angles of the quadrilateral are supplementary. That means I can label here angle A, and here angle B, here angle C, and here angle D. So the theorem is telling us that A plus B must be equals to 180 degree, and C plus D must also be equals to 180 degree, right? Good. So we have come to the end of this video. Please don't take this video for granted because it's the foundation for solving problems in quadrilaterals and geometry. You must know the properties of each shape, either quadrilateral or polygon. So thank you. Thank you for watching. I wish to see you in my next video. God bless you and bye.